Okay, so I wrote these slides, assuming some knowledge, but some I won't assume. So I'll try to explain it from briefly, and we'll have some workshops, some scenarios. So I think last week we used TrackMe. This week is even more irrelevant because what we'll do today is you will pretty much exploit the machine in the worst way possible, in a way that you have control over, or a pathway to control the machine in a more complete manner. And the reason why we want to use our own platform is that we are scared of it. That's what you can do. But I hope to invest in this area so we can have the platform based on maybe around VMs, so we can have some security. So if you break to our box, you can still break the VM, and it won't really cause any damage to our own root VM. But anyway, so first of all, let's start with the question: what is a shell? Maybe we should. Okay, I put it on the screen, but maybe let's ask some of you people: have you ever used a shell before? Yeah, Matthew. Maybe. I mean, have you ever used a shell? Yeah. Which one? Okay, yeah, fair choice. Anybody else? Any other shell? Hey, yeah, fair choice as well. Sure, on Windows. So pretty much, the point about this definition is that I think it's my own definition. It could be lacking in some areas, but the point is that once you have a shell, you can issue code to the machine, and it would run the code based on your permissions. So that is a really key point, that our goal with a shell is that we want to trick the server to giving us a shell back to our machine, so we can run more code without anything to set up an RCA. So it's pretty much, but it still depends on having an RCA. So an RCA stands for a remote code execution. It's when you find a vulnerability on the machine that could, on any software, that could give you the access to run more code that the author didn't really intend for it to run, which is pretty bad. Okay, so first of all, let's do some history. The first shell in Unix is the Bourne shell, SH. I think it's pretty the main standard for shells today. And it was I say, more interactive, and it has more capabilities around scripting, pipes, redirects, some more logic, and threading as well. And Bash is pretty much just the GNU version of that. So they pretty much took the spec of the Bourne shell, made Bash, so it's more open source. And I think when you are attacking a server, you might have a Bash on it, which you can use as part of your RCE to pretty much run Bash and pipe all of the input and output to your machine via TCP. And also just because that's my shell, this SH, they put my config in there just to flex. But much more interactive than Bash. It's fun to have, but for us, we won't really care about this. Also, similarly, Fish as well. It's also like similar to Bash, but it's even if you want even more control, I guess. Yeah. Fair enough. And PowerShell is used. I think it's a fair choice for Windows, and it also can run on other platforms as well. And it can be relevant if you are attacking a Windows-based machine. But for now, we'll focus on Linux because it's easier to, I guess, teach in a way, for me at least. So why should you care, right? As I said before, when you find an RCE, your best option is to try to pop a shell to your control. And because you can at least in Unix and Linux, you can pretty much pipe input and output to a file. That file can be a TCP port as well. So it's pretty much the very, I guess, easy in the sense that you don't have to have physical access to the machine in most cases. And if you have pretty much a shell on the machine, an RCE, a network access, it's very much like a clue to try and get a reverse shell. Okay, so in this workshop, we'll help you to do I think we have two challenges. One of them involves Wireshark, which we learned last week. And Wireshark, I think, is very cool because it shows you how someone got the shell in the first place, and you have to follow that as well. And so because you get, after you get a shell, I can't really tell you what to do because at this point, you have more control of the machine. You can choose to get privileges. You can choose to run more code. So when you get a shell, it's pretty much game over for your company, and it can begin for you. And yeah, so I think, has anybody heard of Netcat before? Okay, so Netcat is really useful. It's a very simple tool. All it does is that you give it a port number, and it would open a port and wait for a response. And then, so it's used to pretty much open a port on your end, wait for a shell to connect to you, and it will keep it open until you terminate. So this is the main tool we use on our end to wait for the victim host to talk to us after we deploy the RCE. And also, Bash is used on the victim's end. So Bash will run as a shell, but will pipe to TCP. And if not, SH is also an option. And yeah, so from now on, I think I'll pause the recording. For the Cod Caper, we have a machine here, the IP address. Nothing about it, maybe except that we might find in RCE. And so, okay, maybe let's open to the audience. What tool should you use first? We have an IP address. Yeah? Yeah, definitely. Any? Okay, so I think I'll use my favorite config for that. So on Kali, there is a version of Nmap installed. So Nmap stands for Network Mapper, I believe. And oh yeah, makes sense. Yeah, so let's make it bigger actually. Let's make it bigger. Okay, so you pretty much run Nmap, and for me, I like to, as the first step, I want you to get the version number. So Nmap can try to pick up what version of the software they're using. So I think it has S3, I believe. Let's put the IP address for now. And then by default, it will enumerate through common ports. We might have to give it some other port numbers, like some other range, I would say. So actually, pretty good thing to do as well is, I think I started. Okay, so Nmap, what Nmap does is that we have an IP address. We want to find what possible network activity is doing. So we can pretty much just go over open ports, like for TCP ports, and each time when it finds an open port, it would either print it to the console live, or it would wait until we find all ports. So I like to just put the option for verbose, just so we get live updates. Okay, here we go. So we have 2280. Okay, so what does port 22 generally mean? Any ideas? Yeah, SSH. So SSH is pretty much a shell that we expose to the outside network. And normally we have a password or like some key for it. So, but as a clue, it's good to have a set because we have a target to get in. Also have port 80. So port 80 is normally for a web server. So we probably have some website running, and yeah, those two are doing only 2 ports. So pretty simple. So actually, let's take a look at the machine, right? So just put the IP address. Okay, yeah, okay. I need to boot Kali from GUI. Actually, okay, I have an idea. Just let's try. Just git list. Okay, so HTML. So okay, I think I might have to boot Kali into a GUI because I only have it as a shell for now. Let's try to see what it is. Okay, I'll attempt the annoying thing of reading HTML with the Ubuntu logo. Okay, so it's running Apache 2. And okay, so this looks like the default Apache entry page, right? Like when you have so it's pretty much just Apache. Actually, let's look back at the version number. So we're running OpenSSH 7.2 and Apache 2.4.18. So these version numbers are pretty good to take a note of. And of course, we're running Ubuntu because we got the hint from the Apache entry page. And let's see. Okay, so because this is a walkthrough in TrackMe, they try to help you a bit to learn. So the map, we've already done this. So we have the HTTP title. So let's try. So they asked for the HTTP title. Let's try to grab for it. Okay, so I think by HTTP title, they mean the title of the HTML page, which I think is just this. I think they just meant you to look through the response from Apache to try to figure out what everything means there. But it's just to pretty much get you to understand what systems are running. Okay, web version. So okay, so we have a website. It will host some files on it, but we don't know what files. So we can pretty much there's a program called I like to use called GoBuster. You give it the IP address, you give it some word list, some extensions to try, and it will go over the word list and check every item and give you a summary of every file it found that is opened to the web. Which is good to check if they post any secret files or maybe files that they shouldn't really expose to the web. So I think if you follow their guide on the page for TrackMe, they will tell you what to do. But I think I'll try to do the way I know. So okay, I don't have GoBuster. Let's try install sudo, of course.
2 hours later.
Okay, so we have a GoBuster. Let's try again. So we have GoBuster, and GoBuster can pretty much enumerate through many things, but we want to enumerate through directories. So we there, and we give the the IP address was here, and we think to give it some list to go through. So a word list I like to use. I think okay. Let's see where the word list. So I think it would be user share word list. Let's see. So I think it'll be in DRB, like Dear Buster. And last time I tried the big word. And we can also give it an option for some file types. So let's try two things. Let's try PHP, because PHP is very, I guess, common to have issues with, and some text files as well. Now it will pretty much, yeah. So it will show you a live report of what it found and how many more things are left on the list.
6 hours later.
Okay, I think for now, I think we get the main gist. Okay, so I think from my notes, I can see that this is the only meat of this challenge. Okay, I think I might have to run a browser. Okay, so here's how the HTML page I was looking at it from Carol looks like. So we found a page under /.administrator.php. Let's look at that. Administrator.php. We don't have any typos. Let's try. Just copy it from here. It's fine. Funny. Okay. Oh wait. That's why I don't run GUI with the laptop. Slow. Let's go back to YouTube. Okay. So we have some admin login. So pretty much from this, what I hear, that we need to try to get a, yeah. Okay, so here's the HTML for the admin page. It's just PHP. We have a form in the HTML, use the username and password. So there are probably two ways to do it. One way is to use Hydra to brute force the password, like we did on week 2, I believe. This time I'll try to use a different tool. So I think, how many of you know about SQL injection? Okay, yeah, fair amount. So this tool won't teach you how to do it, but it's a very cool way to automate it. So this tool give it like the endpoint of the form. So it would pretty much submit this form for you, and we use some SQL injection patterns that to try to brute force, or to maybe to try to find a misconfig on the database end. And so our point is to pretty much dump the entire database from this form. So this form would give out a response with HTTP, and we can use SQL map. I think it should be built into Kali as well. Yeah. So I think to give you like some hints on the website. Yeah. So I think we'll use all of these flags for SQL maps, but I think let's do it pretty quickly.
While Omri does that, I'd just like to point out that for those of you who are confused by what's the answer to task 3, it's administrator.php. That's what they meant by the important file on the website. That is it. And then now that we know that that's the important file, we have to break into it for more important information.
Okay, so when you start running a SQL map, it will give you some prompts, And so if on the form, we want to test the form, why not? And I think I just went to defaults. So let's try the defaults, right? For now, let's go to the default. If then we'll try again with other defaults, but let's try to give some control over what it will do. So it's running per running in MySQL, very common. So the reason why I thought it might be a WordPress because in WordPress they use PHP and MySQL a lot, and maybe this will be the admin page for WordPress.
While that's running, because I know we have quite a few new people here, put your hand up if you don't know what an SQL injection is. Be honest, if you don't know what an SQL injection is. Okay, so a very, very quick explanation is SQL is used for databases. So basically storing information in a great big table that you can retrieve quickly. So the way that a lot of login pages work is, SQL's, their requests are like queries. So it says something like where username equals username and password equals password, do something. So a lot of the way that login pages work or work in CTS, they shouldn't work like this in real life, is we'll say, from this database of users where user equals whatever's in the username field, so whatever you type in, like your name 123, and password equals password, let this person in basically. So it'll go check your username. Yes, the username is X, their password is Y, X is in the same row as Y, ding ding, we can let them in. For us hackers, this is great because if they've got a really badly phrased query, we can, instead of injecting a legitimate username, we can inject some code instead, because in SQL, we can escape out of the command pretty easily. So we can either, a very, very famous one is you put a little apostrophe, because in SQL, that's like, close that, that's a string, everything else afterwards becomes code. So a very famous one is where username equals username, and in the password field, you put apostrophe 1 equals 1. Basically saying where username equals admin, for example, and this is true, let me in. And because 1 equals 1 is always true, you're going to get the password. So this particular tool is really good at testing the obvious SQL injections for you. Because yes, you could spend ages trying to come up with your own payload. Okay, if I make the username this, and if I put this many commas here and this many apostrophes, and I use this command, I'll get the password. This tool just makes it a lot faster, because trying to figure out how an SQL table is structured so that you can exploit it manually can take a lot of time. And we are lazy, and we have computers with fast processing times. So basically what this is doing, if we look at the current one, let's say MySQL union query random number. So it's testing an injection basically where it's saying okay, there's a whole bunch of them here now. Yeah, we'll just look at this one here, where it says payload username equals nonsense, basically. Like select case when. It looks like a bunch of nonsense, but this is the kind of payload that we can use to exploit an SQL database, because it's going to look at that and it's going to go, okay, this username is nonsense, and I'm going to just parse this code straight afterwards, and then it'll run the code in its server, and then that's how you can get a lot of information like this.
Yeah, so we found, now we know that they store their username and password in clear text. It's pretty bad. And I think sometimes in this, you should have the reverse shell, the point of this workshop. Yeah, so command, okay, so we want to reach here to run commands pretty much. But for now, we know the username and password. And so forms of SQLi, I think that's not really important for now. And we have to move on to actually run code. So we have the username, we have the password. Let's see.
If you have questions about SQLi, because it's a really big part of cybersecurity, feel free to come and ask us at any point, like just bug us about it. Can you go to the MySQL command?
Oh yeah, okay, so yeah, right here. Yeah, no worries. So we pretty much just give it the form, what we found. So it uses this form to inject the SQL, and we want to still to use the form and to dump the database. So in the end, we want to see what they have on their database, and it will try many things. And I think for now, this is the default. So I think if you just press enter for every question it gives you to the default. And in the end, let's see. So they found okay, they also use Ubuntu and Apache as well, use MySQL. And in the end, we got the username and password because they were very dumb and they stored the password in clear text. Should be hash. So now let's see what we need to do next. So MySQL. So now so now we can pretty much run some form of code on the server. I mean, it's still SQL, but let's see what they recommend. So okay, we need to use netcat. Okay, so we have two methods. Let's use netcat because we want to get a shell. So pretty much we found some RC. So think with a SQL map, you can MySQL and some servers, some databases have their own shell, like their own shell that you can run through the database. You can run commands on the OS, and that is the only way a REST shell, but through more layers, I would say. So I think let's see what I did here. Okay, so I think I need to open the GUI again for the browser. If you notice from the stream, this laptop is very low powered, and I tried to not run a VM with a GUI on it, but now I think I have to. Okay, we were here, right? So let's try the password and the username. Oh, wait. Control, not command. Again. And now okay, so so they pretty much have a shell from the browser. Pretty bad idea to do it in practice because you don't want any user to run commands on the from the browser. So now in a way we have a reverse shell, but we want to get a shell on our own terminal, not on the browser. So okay, if we have a shell, right, we can run commands. What can we do? What would be the first command you run?
Sudo rm/rf/.
Yeah, I mean, if you want to nuke the machine and you have sudo permissions, yeah, maybe that would work. Yeah, okay, let's try. So what command would you use? Just to spare some discussion. Oh, yeah, why not? So groups is, let's see. So we are pretty much okay, so this name, www.data. I think it's a very common name for Apache servers. That they have a separate user on the machine and a group for the user to run the server. So if you manage to pop a shell on this server, it won't give you a root shell immediately. It will give you a shell for this user, which would have to find a way to get to root. So actually, let's see. I think let's try to run. Let's see what. So the server is running from this path on the backend. So let's see. So let's see what files are in its directory. Okay, so it's just the HTML for the entry page, the PHP, and this weird page that we would never have found without. Okay, so I think this weird page we can look into it if we want to, but So because we can run a shell. I mean, we can run commands initially. Let's see if we can. So the one good file to try to read would be password. Oh, let's put slash. So I think I'll just copy everything to more sensible format because actually no, it's fine. Where's my mouse? Okay, so the user. So they have. I think the main username is Pingu. Pretty much, they have a shell. So whenever they log into the computer, they will have a shell. They have a home folder. There's also SSH, MySQL. So this file describes every group on the every user on the server, if they have a shell, if they have a home folder, and their group ID. So okay, so I'll put it in again. So it's a file that you can print. And I think depending on how you configure this server, you can block this from happening if you don't give access to the group to this file. Okay, yeah, good point. I'll make it bigger. Can you see it now? Because they messed up. So I think it's a case of how much they mess up. So no, a good admin would not allow any user to read it. Maybe just root and himself or herself. Actually, I'm not sure, but I think as a good admin, you want a rely on default. You would tighten everything up. So /home is like the folder on Windows for /users, like the folder where every user's home folder is found by default. You can so we have two users, Papa and Pingu. I think Papa might have appeared before, but I maybe missed that user's entry in the file. But I think Pingu looks more. I mean, from this icon of Pinguin, I think we should probably focus on the Pingu user. Let's say /home/Pingu. Okay, so we have the bash history. Could be useful. So this is the file that shows every command they typed. Up to some boundary, maybe 1,000 commands, could be less, could be more. They also have font tools installed on the machine. I don't know why. Oh, okay, this folder is pretty good to have. So this folder for SSH, it might store private keys. Yeah, I think it's slash. We can try. So I think because we managed to list files on the folder, we probably have access to it. So this machine is a very bad case of how much you can mess up as an admin if you don't close the gaps on your machine. So the fact that I can list files on this folder, not being Pingu, is bad. So if you ever run a server at your home, at your work, close the gaps. Don't make your permissions wide open. So I think I'm really, if you want, you can probably look into their bash history to see what commands they typed before. But I'll go for the juicy stuff and see what file they have on their SSH folder. So /home/pingu /.ssh. So dot is in Unix dot. By default, dot would hide the file for being listed in the default view. But if you have the -a, like if you run ls with the -a flag, it would list everything. But let's see. Okay, we got a public key for SSH and a private key. Normally, normally we care about the private key more because the private key is what blocks most RSA, most SSH attempts from most brute force SSH attempts. So let's print the private key. /home /pingu.sh. And this file name, this ID RSA is very common. So they're probably using an RSA key. So they have the public key .pub and the private key. And here's the private key. Oh yeah, no worries. Okay, so I think let's try to get to let's try to pretty much pop a shell on the machine.